Welcome to the Advisory Science channel. What is an electric circuit? Electricity is energy that can build up or flow through materials. Some materials, like copper, allow electricity to flow easily. We call them conductors. Other materials, like rubber, block electricity, and we call them insulators. For electricity to work, it needs four things. Firstly, a closed-loop circuit for the electricity to flow through. Secondly, a power source, like batteries, to push the electricity. Next, it will need conducting wires to carry the electricity. And finally, components, like light bulbs, that convert electricity into useful forms like light, movement, or sound. So let's see how this works inside a torch. When we flip the switch, this creates a closed-loop circuit for electricity to flow around. The batteries push electricity that flows through the wires. Once the electricity reaches the metal filament that's inside the bulb, the tiny wire heats up and glows, producing light energy that illuminates the torch. Understanding how electricity flows in loops and how components use it lets us design many helpful appliances and gadgets that make our lives better. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio. Welcome to the Advisory Science channel. In 1800, Alessandro Volta invented the first battery from metal discs. Batteries allow portable electricity from chemical reactions, not from outlets. This is useful, for example, for hearing aids. Battery strength is called voltage, and this is what pushes electricity around a circuit. The higher the battery voltage, the stronger the push from the battery. To increase voltage, we can use higher voltage batteries. Small batteries are 1.5 volts. We use them in watches, remotes, and calculators. Large 12-volt batteries can be used in cars and boats. We can also increase the voltage by adding more batteries to the circuit. More voltage means a greater push of electricity, making bulbs brighter, buzzers louder, and motors turn faster. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio. Welcome to the Advisory Science channel. What are some electrical components? Electrical engineers design gadgets using circuit components like bulbs, buzzers, and motors. Light bulbs have a thin heating wire that glows when electricity flows. Buzzers have a metal plate that vibrates when electricity flows through it, creating a buzzing noise. Motors use electricity to flow through coiled wires to make a shaft spin. Switches control gaps in circuits to turn flow on and off, conserving power. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio. Welcome to the Advisory Science channel. What are circuit diagrams? Engineers use special pictures called circuit diagrams to show how circuits work. These diagrams use simple drawings to represent each part of a circuit, like a flashlight's battery, wires, and bulb. Engineers also use symbol diagrams, which use special shapes instead of detailed drawings. Each shape represents a specific component, like a battery, wire, or switch. Symbol diagrams still show how electricity flows in a circuit, but they use shortcuts to make complex circuits easier to understand. Here are some common symbols used in circuit diagrams. Picture circuit diagrams are useful for seeing what each part of the circuit looks like. Symbol circuit diagrams are useful for seeing how each component in the circuit is connected. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio. Welcome to the Advisory Science channel. Electrical safety. Electricity is very useful, but it can also be dangerous if not handled properly. Metals like copper are excellent conductors, and electricity can easily pass through them. Water is also a good conductor because it contains minerals including dissolved metals. Human bodies conduct electricity because we have water and minerals inside us. An electric shock occurs when electricity goes through someone's body, causing pain, burns, or injury. A risk assessment identifies possible electrical dangers and how to prevent them. Wires with exposed metal can shock anyone who touches them. It's important that wires are covered in insulation. Overloaded outlets can cause electrical fires. A surge protector can prevent too much electricity from going through to appliances. We must avoid the use of electronics with wet hands or near water to prevent electric shocks. And appliances must be kept away from sinks, bathtubs, and other wet areas. Why not check out the free resources for this and other lessons? Or inquire about the full curriculum. Link in bio. Welcome to the Advisory Science channel. Lots of events have taken place in the development of electricity. Let's look at some of them and see how they've changed electricity over time. Firstly, the ancient Greeks and Romans. When they rubbed a stone called amber against fur or wool, they noticed that the amber became attracted to feathers and leaves. This was a type of static electricity, but they didn't yet know the science behind it. In America in the 1700s, a scientist called Benjamin Franklin demonstrated that lightning is a form of electricity. By flying his kite in a thunderstorm and experiencing a spark through the string, Franklin proved that lightning and the amber effect were actually the same phenomenon. They were both forms of electricity. In the late 1700s, an Italian scientist called Luigi Galvani discovered that electricity makes frog legs twitch. This suggested the presence of electricity in living organisms. Another Italian scientist, Alessandro Volta, invented the first battery in 1800. Volta's battery offered portable, longer-lasting and more reliable, continuous electricity compared to previous methods, and this paved the way for future technologies. In the late 1800s, Nikola Tesla, a Serbian scientist, developed ways to transmit electricity over long distances. And this allowed widespread electricity distribution to people's homes and businesses. In the late 1800s, an American inventor, Thomas Edison, commercialized the light bulb. And this changed indoor lighting and made electricity easier to use in the home. We have lots to thank these and other scientists and inventors for. Will you be part of future advancements in electricity or the invention of technologies that use electricity? Why not check out the free resources for this and other lessons, or inquire about the full curriculum? Link in bio.